Hello, I'm Dr. Megha Bhamre, working as Assistant Professor in KVN Naik College, Nasik. We will see the topic vector space. A vector space is a non-empty set V whose objects are called vectors, equipped with two operations called addition and scalar multiplication. Now, closure axiom. For any two vectors, UV belongs to V, U plus V also belongs to V. Second closure axiom. For any vector u belongs to V, a scalar alpha into u belongs to V. Then addition axiom A1, that is u plus V is equal to V plus u, commutative property for addition. A2, u plus V plus W is equal to u plus V plus W, means associative property for addition. A3, there is a zero vector such that u plus 0 bar is equal to u. A4, for any vector u, there is a negative factor minus u such that u plus minus u is equal to 0 bar. Multiplication axiom M1, that is alpha into u plus v is equal to alpha u plus alpha v. Multiplication axiom M2, alpha plus beta into v is equal to alpha v plus beta v. M3, alpha beta into v is equal to alpha to beta v. And M4 is 1 into u is equal to u for 1 belongs to R. Now we will see the example. Let V is equal to R square is a set of element u which is equal to u1, u2 such that u1, u2 are real numbers. For u is equal to u1, u2 and v is equal to v1, v2 belongs to V which is equal to R square, and alpha is a scalar which is also a real number. Then vector addition is defined as u plus v is equal to u1 plus v1, comma u2 plus v2, and alpha into u is equal to alpha u1, comma alpha u2. Show that V is a real vector space with respect to defined operations. Now we will see the solution. Let u and v and w are the elements of V. Alpha beta are real numbers. Then closure axiom, that is u plus v is equal to u1 plus v1, comma u2 plus v2 by given vector addition and which also belongs to V. Hence C1 is satisfied. For C2, alpha into u is equal to alpha u1, comma alpha u2 by scalar multiplication given in example and which also belongs to V. Hence C2 is also satisfied. Now A1, that is addition axiom. U plus V is equal to u1 plus v1, comma u2 plus v2. Here we have to show that u plus v is equal to v plus u, and therefore we write u1 plus v1 is equal to v1 plus u1 and u2 plus v2 is equal to v2 plus u2, since commutative property hold for real numbers, and hence it is v plus u, and therefore we say that A1 is satisfied. Now A2, consider u plus v plus w which is equal to u1 plus v1, comma u2 plus v2 plus w1, w2, and which is equal to u1 plus v1 plus w1, comma u2 plus v2 plus w2, and which is equal to u1 plus v1 plus w1, comma u2 plus v2 plus w2, because associative property is hold for real numbers, and hence we can write u1, comma u2 plus v1 plus w1 comma v2 plus w2, and which is equal to u plus v plus w. That is, associative property is also hold for addition. A3 u plus 0 bar, which is equal to u1 u2 plus 0 comma 0 is equal to u1 plus 0 comma u2 plus 0, and which is equal to u1 comma u2 means u. That is, A3 also holds. Means 0 bar is equal to 0 0 belongs to R square is a 0 vector. Now for A4, u is equal to u1 u2 which belongs to R square. There exists minus u, means minus u1 comma minus of u2 belongs to R, such that u plus minus u is equal to 0 bar. Means negative vector also exists. Now for M1, take alpha into u plus v, which is equal to alpha into u1 plus v1 comma u2 plus v2, which is equal to alpha into u1 plus v1 comma alpha into u2 plus v2, which is equal to alpha u1 plus alpha v1 comma alpha u2 plus alpha v2, and hence which is equal to alpha u1 comma alpha u2 plus alpha v1 comma alpha v2. If we take alpha as a scalar as a common factor, then we get alpha into u1 comma u2 plus alpha into v1 comma v2, which is equal to alpha into u plus alpha into v. Hence, distributive property also holds. Now for M2, alpha plus beta into u is equal to alpha plus beta into u1 comma u2. Multiply alpha plus beta to each coordinate, and hence we get alpha plus beta into u1 comma alpha plus beta into u2. Which is equal to alpha u1 plus beta u1 comma alpha u2 plus beta u2, and here it is equal to alpha u1 comma alpha u2 plus beta u1 comma beta u2. Take alpha as a common factor, and hence it is equal to alpha into u1 comma u2 plus beta into u1 comma u2, and this value is equal to alpha into u plus beta into u. Therefore M2 is satisfied. For M3, consider alpha beta into u, which is equal to alpha beta into u1 comma u2, which is equal to alpha beta into u1 comma alpha beta into u2. Take alpha as a common factor to each coordinate, and hence it is equal to alpha into beta u1 comma alpha into beta u2, and hence it is equal to alpha into beta u1 comma beta u2, which is equal to alpha into beta into u. M3 is satisfied. For M4, 1 belongs to R. 1 into u is equal to 1 into u1 comma 1 into u2, and which is equal to u1 comma u2, which is nothing but u. Hence we can say that M4 is also satisfied. Therefore V is a vector space because it satisfies all 10 axioms.